As you saw in the last video, clusters can form when we use the linear probing algorithm. And these clusters reduce performance. To solve this problem, we can use quadratic probing. I know, it's a fancy word, but quadratic comes from quad, which means square. So here's the formula for linear probing. If we change I to I squared, now we have a quadratic equation. So how is this going to solve our problem? How is this going to prevent clustering from forming? Well, with linear probing, we increment I by 1 in each step. So new key value pairs get stored next to each other and form a cluster. But if we raise I to the power of 2, our key value pairs are going to get spread out more widely. Now, just to clarify, I've simplified the formula for calculating the index. So here we don't see the modulus operator, but in both algorithms, it is possible that I gets larger than the boundary of our array, so we should always reduce it to the size of the array. So the quadratic probing solves the clustering problem, but it has another problem. Because we are doing big jumps to find an empty slot, we may get back to the beginning of the array and end up making the same steps. So we may end up in an infinite loop. With linear probing, we wouldn't have this problem because we may find an empty slot right after the current slot. So next we'll look at another algorithm that solves this problem.